section B of types of chemical reactions, and we are going to talk lightly on combustion. Combustion is the process or a reaction. Is a process or a reaction in which a substance combines with oxygen. The process in which a substance combines with oxygen with releasing or evolution of energy in form of heat and light. Heat and light. So what is combustion? It's a reaction in which a substance combines with oxygen with evolution of energy in form of heat and light. This is a very common type of reaction that occurs in day-to-day life. For example, in our gases at home, that is propane, hydrocarbon, that burns to produce heat that we use in cooking. The firewood that we use, oxygen must be required for combustion to take place because oxygen supports burning. Burning is combustion. So when a substance combines with oxygen with evolution of energy in form of heat and light, that is combustion. So even in cars, automobiles that we use, that is petrol, diesel, is burnt in the engines to produce heat and light that makes the piston moves so that we can have the energy to move the car or to power the car. So these are common type of reaction that occurs in day-to-day life. So, for example, hydrogen is a gas. Hydrogen is a gas. When you combine it with oxygen, hydrogen is a gas. It burns with a blue flame. When you react oxygen with hydrogen, you are burning hydrogen. This is burning of hydrogen in air or in oxygen. It gives us hydrogen oxide. Hydrogen oxide is water. So hydrogen plus oxygen is hydrogen oxide. Hydrogen valence 1, oxygen valence 2. So the formula of hydrogen oxide, which is water or steam, is H2O. So this is combustion. When a substance combines with oxygen with evolution of energy in form of heat and light. For example, oxygen, hydrogen burns with a blue flame. Burns with a blue flame. Another common type of reaction is coal. Coal is carbon. Charcoal is carbon. Is fossil fuels. Fossil, such as coal. Charcoal is carbon. Carbon, solid, burns with oxygen gas to give us CO2 gas, to give us CO2 gas. So this is combustion. Carbon combines with oxygen to form carbon dioxide. In this reaction, we evolve heat. Carbon is combined with oxygen to evolve heat and forming carbon dioxide. This is combustion. So oxygen is involved. Balancing these two equations, I can see H2, oxygen, O2. So oxygen is not burned. I'll put a 2 here to balance the oxygens. And because I've balanced the oxygen, the hydrogen is 4. 2, 4, this is 4. So I'll put a 2 here so that hydrogen is balanced. So we have 4 hydrogens, 4 hydrogen. Oxygen 2, here 2. Carbon is 1, here is 1. Oxygen is 2, here is 2. Another common type of combustion here, another common type of combustion is when a hydrocarbon. Hydrocarbon is now the petrol, diesel, the kerosene, the candles. They are hydrocarbon made of carbon and hydrogen. When you burn a hydrocarbon, carbon and hydrogen is a substance that contains carbon and hydrogen only. So hydrocarbon is a substance that contains carbon and hydrogen only. This one will continue. So hydrocarbon, hydrocarbon is a substance that contains carbon and hydrogen only. So, for example, the carbon from the hydrocarbon from biogas is methane, is CH4. Methane CH4 is an alkane. So CH4 gas, when you combine it with oxygen gas, is going to give two products. It's going to give carbon dioxide gas because of carbon in the hydrocarbon, plus water because of hydrogen there. So the equation is that way. Balancing it, carbon is 1, here is 1. So this is an arrow. To the right is the product, to the left is the reactants. Methane is the reactant. Methane is the reactant with oxygen that propels combustion. So balancing the equation, carbon is 1, here is 1, hydrogen 4, here is 2, oxygen 2, here is 3. So what can I do? Because hydrogen here is 4 and here is 2, so I put 2 here to balance the hydrogen. So hydrogen becomes 4. But oxygen is also 4. So what do? I balance oxygen because it's O2 and here is 2, 4. I will put a 2 here so that the equation is now fully balanced. Another final equation, we have many types of combustion reactions. Even when magnesium combines with oxygen to form magnesium oxide, that is combustion because we release heat and light. So, the one that we use at home, propane, C3H8. The gas that we use at home to cook, that is propane, C3H8. When you burn it in oxygen, it also forms carbon dioxide and steam. Water, but in form of steam. That's why you don't see that water. It's in form of steam. So it gives us carbon dioxide gas plus water. So balancing the equation, carbon 3 here. We have 1, hydrogen 8, here we have 2. So balancing, I'll put a 3 here to balance the carbons. Carbon is 3. So, and hydrogen is 8. Hydrogen is 8, and here is 2. So I put 4. So looking at this equation, hydrogen is 8 already. Carbon is 3 already. We have balanced that. But oxygen, 3 times 2 is 6. 6 oxygens. 4 times 1 oxygen, that is 4 oxygens plus 6, it's 10. So I will put a 5 here to balance that equation. Therefore, it means when you burn 1 mole of propane, 1 mole because we don't have a coefficient there, burns in 5 moles of oxygen gas to give 3 moles of carbon dioxide gas and 4 moles of steam. Or this can be gas or liquid, or and that is combustion. Thank you. Let's meet in our next section C for another type of reaction known as decomposition. Thank you.